we're going to look at two more problems that involve rational functions and graphing. So here's the first problem. R of x is equal to 8x squared plus 26x minus 7 divided by 4x plus 1. We're going to graph this. And if you remember from the last video, we had 4 basic steps to graphing this. The first step is to factor the numerator and the denominator. The denominator is completely factored, so let's keep it like it is, 4x plus 1. And then we're going to factor the numerator. Now you might want to go and practice this, see if you can figure out how to factor it. This will factor into 4x minus 1 times 2x plus 7. I'm not going to do that work because we've done such factoring before a while back. So that's something you need to review if you have trouble with that. Okay, so now we have the numerator factored. We ask ourselves, what is the domain? So the domain is all the values of x that we can plug into the denominator here and into this function. So the only problem we have is when we set this 4x plus 1 equal to 0, you see that when x is equal to negative 1/4, then we get 0 in the denominator. So the domain is all real numbers except for this negative 1/4. From here we can figure out the vertical asymptote. Notice that we cannot reduce this. This is completely reduced already. So there's nothing we can cross out in the numerator and the denominator. So since we have something that's reduced, we just look at the denominator and see where we have problems when we plug in a value for x and we get 0 in the denominator, and that's x is equal to negative 1/4. So what we're going to do now is we're going to actually sketch this vertical asymptote. So let's say this is negative 1. I'm going to just do some lines here. And let's do some lines up here. I think I might actually, I'm going to make these a little bit smaller because I think something's going to happen where I'm going to need more space. So maybe something like this. Okay, so negative 1/4, that's about 1/4 of the way here. So let's say right here. So we just draw a dotted line, and that is our vertical asymptote. X is equal to negative 1/4. Okay, now let's find our horizontal asymptote or our oblique asymptote. So I'm going to erase this. Now remember that you have a horizontal asymptote when the degree of the numerator is less than or equal to the degree of the denominator. Here the degree of the numerator is 2 and the degree of the denominator is 1. Let's write that down. The degree of the numerator is 2, the degree of the denominator is 1. And since the degree of the denominator is 1 less than the degree of the numerator, in other words, the degree of the numerator is 1 more than the degree of the denominator, we're going to have an oblique asymptote. Let me write that down. And we found this oblique asymptote, I believe, a few videos ago, but we're going to do it again in case you forgot or just need more practice here. So to find the oblique asymptote, you actually do long division. So the oblique asymptote is going to be y is equal to ax plus b. We just have to find the a and the b. And so we take this 8x squared plus 26x minus 7, and we divide it by this right here, which is 4x plus 1. Okay, so 4x plus 1. Okay, and now we're going to do this division. So we ask ourselves what we need to multiply 4x by to get 8x squared, and that's 2x. So 2x times 4x gives us 8x squared, and then we also multiply this 2x with the 1, which gives us 2x. Subtract this, subtract, subtract. We get on the bottom 24x, and we carry down the negative 7. And then we ask ourselves what we need to multiply 4x by to get 24x, which is 6. So 6 times 4x is 24x. Then we get plus 6, subtract, subtract. And then that, I think, is negative 13. This is your remainder here, but this remainder doesn't matter when we're talking about oblique asymptotes. the A is 2 and the B is 6. So let's graph this line, 2x plus 6. In fact, let's also write it here. Just get rid of all of this. Okay, so y is equal to 2x plus 6. The y-intercept is 6, so that's right here. And I'm going to erase this piece right here. We know what that vertical asymptote is. And then we have up 2 over 1 or down 2 over 1. So down 2 over 1, down 2 over 1, and so on. I think this goes through, we plug in -3, yeah, it goes through that. So now I'm going to make a dotted line right here. Just like that. So we have 2 dotted lines. Now remember that for our vertical asymptote, we cannot cross this line. And the oblique asymptote tells us the end behavior. We can cross the oblique asymptote. So the next step is to figure out any x or y intercepts. So let's start with the y-intercept. That's usually the easiest to find. What we do is we plug in x is equal to 0 into this equation. So if we plug in 0, we get 0 plus 0 minus 7 over 0 plus 1. So we get -7. So we have 0, -7. That is a y-intercept. So let's plot that. 0, 1, 2, 3, 4, 5, 6. We got to go a little bit lower here. -7. Okay, I'm going to zoom out so you can see this a little bit better. Okay, now let's find our x-intercepts. To find the x-intercepts, what do? We set y equal to 0. So x-intercepts are next. So we set this equal to 0, and we get 8x squared plus 26x minus 7 over 4x plus 1. Multiply by 4x plus 1 to get rid of that denominator. And this is where that factored form comes in handy. We said that this factored into 4x minus 1 times 2x plus 7. Again, you can FOIL that out to double check that this is equal. And you can see that x is equal to 1/4. And also x is equal to -7 over 2, which is -3.5. Those are our x-intercepts. So let's put dots at 1/4. So 1/4, if this is 1 here, 1/4 is like the mirror image of this one. So we're going to have a dot right here at 1/4. And also at -3.5. So you have to be careful here. Notice that this line crosses at -3. Remember, this line was y is equal to 2x plus 6. And to find its intercept here, you just set y equal to 0, and you'll get -3. And -3.5 is actually to the left of that. Okay, so now we have some points. The next thing we want to do is we want to try to graph this and see if we need to draw any other points or plot any other points to help us graph it. So a few things to remember. This is a function. So we're not going to have 2 dots for the same x value. So in other words, whatever we have down here, we're not going to have up here as well, because if we did that, it wouldn't pass the vertical line test. Okay, so let's see what's going to happen. Here, we might do something interesting here, but we're eventually going to head towards this asymptote. So I'm just going to go ahead and have it send towards the asymptote. You can plot more points, but it's always going to go towards this asymptote. And then you're going to head up, and remember that we only cross the x-axis at these 2 points because those were our x-intercepts. So if we decided to go up and then back down, we wouldn't be able to cross this x-axis. And remember, at the vertical asymptotes, we always have to go near, like go up towards infinity or -infinity when we're at those asymptotes. And since we can't go towards -infinity because we would have to cross this line, we're going to have to head towards positive infinity. So the graph is going to look something like that. Then in this section here, we're not going to have anything. And the reason for that is if we did have something drawn, let's say it looked like this, then this wouldn't pass the vertical line test. You can see that we're going to cross twice, so it wouldn't be a function. So we can't have anything in this section here. Now over here, you can already see that we have 2 points, and you can possibly tell that this is going to go down towards negative infinity with this asymptote. And then this side, well, we're not going to go back through here. We're going to intersect here, and we're going to go up towards this asymptote here. We're going to keep going up, and as this one goes out like this, this is going to curve towards that asymptote. And we're not going to have anything up here because then it wouldn't be a function. Okay, it could possibly do something interesting here, but the overall shape is like this. Okay, let's compare that with a graph. So I'm going to pull up my graphing calculator. So let me share that with you. And we have, copy this function, y is equal to, on the top, 8x squared plus 26x minus 7, and on the bottom, 4x plus 1. And you can see that this graph is very similar to what I was plotting before. Did almost exactly what I said it would do. And you can see that it is going towards some kind of asymptote that looks like a straight line, like we thought it was going to do, and also this vertical asymptote. Okay, let's go back to our document. Here we are. Let's try one more problem. This is another problem involving an oblique asymptote. We have f of x is 4x cubed minus 16 over x squared minus 2x plus 1. So we want to graph this. I'm going to make a plane right here. And we're going to try to make this a straighter line here. We're going to factor the numerator and the denominator. Now for the numerator, we're going to get, we can factor out a 4. So we get x cubed minus 4. And in the denominator, this actually factors into x minus 1 times x minus 1. And this x cubed minus 4, it doesn't break into something times x minus 1. Because if you plug in 1 here, remember the remainder theorem, we talked about this. If you plug in the factor, what you think is a factor, and you get 0, then it is a factor. But if you plug in 1, you see you get negative 3, which is not 0, so it's not a factor. It doesn't factor into this. Also, x cubed minus 4, if you set it equal to 0, you get x cubed is equal to 4, and x is equal to the cubic root of 4. So this is definitely not 1, so it doesn't factor involving this 1 here. Okay, so since we factored it, now we ask ourselves, what's the domain? The domain is all values of x except for 1. And because this is in lowest form here, this most simplified form, we can't factor anything else out. We're going to have a vertical asymptote at x is equal to 1. Let's go ahead and plot that. So here's 1. I'm going to put vertical asymptote like that. And now let's see, are we going to have any holes? There's no holes because we didn't reduce this. The next thing we're going to ask ourselves is there an asymptote that's a horizontal or oblique asymptote? The answer is yes. Notice that this power is 1 more than this power, so we're going to have an oblique asymptote. How we find that oblique asymptote is we take the numerator, which of course we've done before, but I'm going to do again, and make sure you put it in expanded form. Divide it by the denominator here. So we ask ourselves what we need to multiply this by to get 4x cubed. It's going to be 4x. So that's 4x cubed minus 8x squared plus 4x. Subtract everything. We get 8x squared minus 4x. Pull down this negative 16. And then we're going to add 8 here to get that 8x squared. And it doesn't really matter what the rest of the stuff is, because this is what we're looking for. But we can continue to write it and then subtract everything. We're going to get a remainder, but I don't care about that. I just care about this piece. So we have y is equal to 4x plus 8. Okay, so now let's erase this and draw this oblique asymptote. Now, of course, if we had a negative 4x, that would be more interesting. We would have a slanted line going like that. But because it's positive, let's say this is 8 here. We're going to go up 4 over 1. Well, let's see where that intersects this line. So this is 0. So if we go, if we plug in 1 for x, we'll get 12. So at 12, we cross this line here. I'm going to erase this. And I'm going to go like this. It's a good idea to draw some points for this oblique asymptote, because it's going to be helpful when you're trying to sketch the graph. So maybe we should also find out where this line intersects the x-axis. So we set this equal to 0, and we get x is equal to -2. So I'm going to put -2 here, and then just kind of draw this here. So these red dots are not points on our graph, they're just points on this oblique asymptote. Okay, let me zoom out a little bit. So the next thing to do is to find the x and y intercepts. So remember that the y-intercept is where we set x equal to 0. So in that case, f of 0 is equal to, I'm just plugging it into here, it's -16 over 1. So 0, -16, that's way down here. I'm just going to put a dot here. It's 0, -16. And then let's find the x-intercepts. The x-intercepts is where we set this function equal to 0. Okay, multiply by the denominator, you just get 4x cubed minus 16. Factor out that 4, so we got x cubed minus 4. And we're going to do what we did last time. X cubed is equal to 4, so x is equal to the cubic root of 4. Let's put that in the calculator just to get an idea of what that is. So 4 raised to the 1/3 is about 1.6. So 1.6. So I'm going to put a dot. So this is 1. So 1.6 is over here. Okay. So we have an idea of what's happening on this side here. Let's find a point on over here as well. So I'm going to erase this, and let's choose something to the left of -2 and plug it into our function. So let's go with like -3. So if x is -3, what do we get when we plug it in the function? We'll get 4 to the -3 cubed minus 16 over -3 squared minus 2 times -3 plus 1. Okay, I'm going to use a calculator for that. So we get, I'm plugging all of this in the calculator. Make sure you do the same thing. -3 cubed minus 16. And then I'm dividing by 9 plus 6 plus 1. I got -7.75. So I'm going to put a dot at -3. So this was -2, so -3. Okay, so this point right here was at -2, 0 for this function y is equal to 4x plus 8. At -3, so when x is equal to -3, what do we get? We get -12 plus 8, which is -4. So, and that makes sense because we go down 4 and to the left 1. So on this line, we have -3, -4. And the reason I'm doing that is because I want to figure out where this point is. This is -3, -7.75, and I need to know if it's above this oblique asymptote or below it. And it turns out that it's going to be below it because the y value here is -4, and this y value is -7.75. And it's bigger than -16, so it's somewhere around, let's just say it's right here. Okay, so that gives me an idea of what's happening here. In this section of the graph, you can see, now we're going to go towards this oblique asymptote, so we're going to go down like this. And then we're going to turn at some point, and then we're going to head through this one and go this way. We can't go up here because we don't have any more x-intercepts. This is the only x-intercept we have. This x-intercept is pretty close to this line. Now we could either go up or we could go down. Now remember that we're always going to head towards this oblique asymptote. So the idea here is that it's going to go up and towards this oblique asymptote, and this side is going to go down towards this one. If you had instead, let's say you thought it was going to go up like this, well then this side would have to go, because it can't really cross and then come back up, it has to go towards this asymptote. It would have to go like this or something like that. But the problem is it would just touch here. And this negative, where is it at? Right here. When we solved this, we said x cubed was equal to 4 when we tried to factor that. And we got the cubic root of this 4. That multiplicity was 1. So that's not going to happen. It's not going to touch because the multiplicity is odd. It's going to go through there. So the only option for this one is to go like this. And if you are confused, if you can't figure out what we're going to do or which way we're going to go, plot some extra points. So let's say, oh, I don't know if we're going to go up like this or down. Let's plot something to the right of this value. So this was, I think this was 2 that we plugged into the function. We found that this was the x-intercept at 1.6 something. So let's choose like 4 or something, see what we get. And when we plug it in, you're going to see you're going to get something very big. And so that will tell you you're going to head towards this asymptote. And then on this side, you're going to cross and head towards this one. So the graph's going to look something like this. So let's see if we're correct. We're going to plot this in our graphing calculator. So let me switch over. This was the old function here. And now we're going to put in the new function, which is y is equal to 4x cubed minus 16 over x squared minus 2x plus 1. And let's see what we got. Okay, do you see how it ended up looking like how I explained it? You got this side here that goes down like we were expecting. And we even can find the max and the min. And then on this side, you can see that we have something like we were expecting as well, like going down this way and then up this way. Now remember, we're just sketching. We're trying to get an idea of what the graph looks like. And by doing this, I think on your homework, you're going to have problems where they're going to give you the sketches and you have to pick the right one. So by doing it by hand, you can kind of have an idea of what you're looking for.